Okay, I hope you can see my board. So I hope everyone has completed yesterday's work. ആരെങ്കിലും ചെയ്യാനുണ്ടോ ബാക്കി ഹോംവർക്ക്
Sir, ഞാൻ
മൂടിൽ തന്നോ
ആ
എന്താ ചെയ്യാൻ
സാറിന് ഇന്നലെ ഞാൻ ഇട്ടില്ലായിരുന്നു അത്.
പേര് പറയാൻ ഞാൻ എങ്ങനെ മനസ്സിലാരത്
ആര്യ ആര്യ.
വേറെ ആരും ഇല്ലേ? ഇഷ്ടംപോലെ ആൾക്കാർ ചെയ്യാനുണ്ടല്ലോ ഇനി.
സാർ എനിക്ക് മനസ്സിലായില്ല അങ്ങനെ ചെയ്യുന്നത്.
എന്ത് ആരാത്?
സാർ അഭിഷേക് വിനോദ്.
അക്സർ യാസിൻ. അക്സർ യാസിൻ.
സാർ ആ ഗൂഗിൾ ഫോം കിട്ടുന്നില്ല സാർ.
അക്സർ യാസിൻ.
യെസ് സാർ.
അക്സർ എന്താ ചെയ്യാന്?
സാർ ഇന്നലെ എന്റെ നെറ്റ് തീർന്നു അതാ ഇന്ന് ചെയ്യാം.
എലിയാസ് ജോസഫ്. എലിയാസ് ജോസഫ്.
സാർ ഞാൻ ചെയ്തായിരുന്നു.
എവിടെയാ ചെയ്തേ?
സാറിന്റെ വാട്സാപ്പിലൊക്കെ ഞാൻ അയച്ചായിരുന്നു. അത് പറഞ്ഞിട്ട്
മോഡിൽ അപ്ലോഡ് ചെയ്തില്ലേ?
ഇല്ല, സാറ് വാട്സാപ്പിൽ അയക്കാൻ പറഞ്ഞോണ്ട് ഞാനടുത്ത് മൂഡിൽ അപ്ലോഡ് ചെയ്യണ്ടായിരുന്നു എന്നതാണ്.
അൽത്താഫ് മ്യൂട്ട് ചെയ്യും. സോ ഇനിയുണ്ട് അർണോൾഡ്, ആര്യ, അസ്ലം. ഇത്രയും പേരോട് ചെയ്യാനുണ്ട്. അർണോൾഡ് എന്താ ചെയ്യാന്? അർണോൾഡ്
സാർ അർണോൾഡ് പോയില്ലായിരുന്നു.
ഇല്ല സാറേ.
അർണോൾഡ് പോയോ? ഓക്കെ. ആര്യ ഹരീഷ്
സർ
എന്താ ചെയ്യാന്?
സർ ഇതെനിക്ക് മൂഡില് ഓപ്പൺ ആവുന്നില്ലേ?
ആര്യ മെസ്സേജ് അയച്ചല്ലേ? ഓക്കെ. അസ്ലം മുഹമ്മദ്. അസ്ലം മുഹമ്മദ് ഇല്ലേ? Okay, fine. So this was the homework. So before solving this homework, we'll do a small exercise. So this question was, we have a body like this. Okay. So this body is cylindrical body. So it's a roller. Roller it has to be. It is not spherical body. It is a cylindrical body. Okay. അതായത് നിങ്ങൾ പെൻസിൽ ഉണ്ടെന്ന് വെച്ചു. ഈ പെൻസിൽ നിങ്ങൾ ഇങ്ങനെ കാണുമ്പോൾ ഇത് സർക്കിൾ അല്ല. അപ്പോൾ ഇറ്റ് ഇസ് പെൻസിൽ ഇങ്ങനെ വെച്ച് കഴിഞ്ഞാൽ പെൻസിൽ ഇങ്ങനെ അങ്ങോട്ടും ഇങ്ങോട്ടും മൂവ് ചെയ്യും. ഓക്കെ. നിങ്ങൾ ഇതിന്റെ ഈ വ്യൂ ആണ് കാണുന്നത്. അതുകൊണ്ടാണ് ഇതിങ്ങനെ സർക്കിൾ ആയിട്ട്. So it is moving like this. Okay. So let's say I have taken a bigger body, maybe a cup like this, and then I put a small body near to that, something like this. Okay. And a body. So this is the situation. I am just putting a force like this. എത്ര ഫോഴ്സിലാണ് ഇത് പുറത്തോട്ട് കം ഔട്ട് എന്നാണ് നമ്മുടെ ക്വസ്റ്റ്യൻ. ഓക്കെ, സിമിലർ ടു ഇപ്പോൾ ഒരു സർക്കിൾ കാണാം, ഒരു സ്മോൾ ബോഡി ഈസ് ഹിയർ. സോ നിങ്ങൾക്ക് കാണുന്നുണ്ടല്ലോ ഞാൻ കാണിക്കുന്നത് അല്ലേ? സ്മോൾ ബോഡി ഈസ് ഹിയർ. സോ ദ ക്വസ്റ്റ്യൻ ഈസ് ഹൗ മച്ച് ഫോഴ്സ് ഐ ഹാവ് ടു പുൾ ദാറ്റ് ജസ്റ്റ് ലീവ്സ്. ഇതിങ്ങനെ ജസ്റ്റ് പൊങ്ങുന്ന എത്ര ഫോഴ്സിലായിരിക്കും എന്നാണ് ക്വസ്റ്റ്യൻ. ഓക്കെ, അപ്പോൾ അതാണ് നമ്മുടെ ഫിസിക്കൽ ക്വസ്റ്റ്യൻ്റെ ഒരു ഫിസിക്കൽ റെപ്രസെൻറ്റേഷൻ. അതാണ്. So before solving this, what the ideal case of doing is you have to draw a free body diagram. Okay, a free body diagram it's very, very important. Okay, you have to get that skill. Free body diagram. So for example, what I will do is copy this figure. So I'll solve this. I will solve here. Okay. Now I want to draw the free body diagram. Okay. Now let's say this force is not there. I'm just deleting this force. Okay, force deleted. Okay. Now I want to draw the free body diagram. Let's say without force. Free body diagram. Okay. So what I will do, I will make another copy of this. So free body diagram, a term actually I am freeing the body from all the contacts, like all the connections. I am freeing the body. So what I am doing is I am just isolating this body. But this body it is not representing the scenario. So it should be representative. Okay. First I have to see what are the forces acting on the body. Right. So here I can observe that there is a gravity weight that will be acting downward from the center of mass. So from the center there is a weight of the body. So that is there. Then I have two contacts. There's a contact here. There's a contact here. Okay. This contact, contact there will be a force. Contact and the body will touch. There will be some force. There could be some force. Okay. So let's say there is a contact force here and there is a contact force. So this body is putting some force on this. Okay. So in that sense. So what I will do is I will just now isolate this. Then I will draw those forces. It will be more clear. So I have taken this out. Do this. So I'll mark these 2 points. I'll take those points also. Okay. So as I told you, there is a weight here. That's downward. Weight here acting downward. Then there is a force from this object on this body. For every action, there will be now contact force. Okay, there is a force from this object on this body. So let's say I call this as N1. Okay, now how will this N1 act? With a point of contact, perpendicular right and act here. Okay, point of contact. So what you will do? You will tangent. A tangent perpendicular, it will be along this radius. Okay, so this will be my force. So if I want to draw it more clearly, I can do it like this. From the center, connect this point. I'll just make this dotted so that I'm sure what is the direction of the force. I'll call this N1 or R1. Okay. Then there is another contact here. So this body is putting some force on this. So that is second force. Okay. So this is a free body diagram for my body. Free body diagram. Okay. Now, if I want to draw free body diagram of this, that also I can draw. But there is a small catch there. So let's say I am drawing this box. Box. Okay. Now this box is assumed to be fixed here. This box is fixed here. Fix here. Nut here, bolt here. Fix here. It will not move. Okay. So what happens is, normal force, equal and opposite force will be acting here like this. Okay. Then there is no other force on this body. Okay. There is no other force in the weight neglect because it is not of interest to us. Interest in the ball we don't have to think about this. Then we can always think then this is not in equilibrium because it's only force and it has to move. But that is what this support. Support condition. Support condition. This is fixed. In the force this will not move. Okay. Whatever force is coming, equal and opposite reaction will be separated by this support. So equal and opposite reaction will be given. എന്നുവെച്ചാൽ ഇത് ഫിക്സ് ആയതുകൊണ്ട് എത്ര ഫോഴ്സ് വന്നാലും കുഴപ്പമില്ല, തിരിച്ചുള്ള അത്ര ഫോഴ്സ് കൊടുക്കും. അതേപോലെയാണ് ഈ ഗ്രൗണ്ടും. ദിസ് ഗ്രൗണ്ട് ഓൾസോ ഇസ് ലൈക്ക് ദാറ്റ്. For every action, there will be an equal and opposite reaction. Okay, so the ground is also not moving. So that means we can easily assume that same and equal forces is given by the ground. So this is the free body diagram of three bodies. Okay, but most interesting, important one is of this body. Okay, so what I will do is I will draw one more free body diagram. This is without the law. A force illatha free body diagram. It is very important to understand that എന്താണ് free body diagram. So free body diagram എന്ന് വെച്ചാൽ ആ ബോഡി നമ്മൾ ഐസൊലേറ്റ് ചെയ്യാണ്. We are just taking this body out and we are just putting all the forces that comes on the body. That's all free body diagram. Only thing is ഫോഴ്സുകൾ എന്തൊക്കെയാണ് എന്നത് we have to think and put. വേറെ ഒന്നും ചെയ്യണ്ട. Only thing is I have isolated. ഇതിന്ന് ഇങ്ങോട്ട് വന്നു, ഇവിടുന്ന് ഇത് വന്നു, then it is started. Then this is what is known as support. So support is not a body, it is not a body. It is basically something which gives whatever force and extra force with extra force support. Okay, right? So what I'll do is we will try to draw free body diagram of this. Here ball in the free body diagram. Just draw this. Try to draw. You take your paper and try to draw the free body diagram of this. Okay. So meanwhile, I'll draw some more figures. So let's say I'll draw a figure here. So just give me a moment. You can try this also. So try to draw a free body diagram of these two figures. Of this ball and this ball. You can forget about these blocks. This block, it is fixed block. It will not move. So നിങ്ങൾ വരയ്ക്കുകയാണെങ്കിൽ I'll give you 2 moments, 2 minutes to draw this. Then I will draw. Okay. Can make these things more complicated. So I'll put 2 more blocks. So copy book. Then you try to draw the free body diagram. Easy to so I'll take. Okay. So what's your So I'll just call somebody. If somebody can, if you are finished, you can just raise your hands so that I will know that you are finished. I just want the first body. Every body to matter university. Just raise your hands. No one has drawn. Can you go? ആരും വരച്ചില്ലേ? So what is the, there is weight for this, there is nothing else. അത് മാത്രമാണ് ഫോഴ്സ് ഉള്ളത്. ആരും വരച്ചില്ലേ? നിങ്ങൾക്ക് ഞാൻ പറയുന്നൊന്നും കേൾക്കുന്നില്ല. അനിക് ടോം, അനിക് ടോം ഉണ്ടോ അവിടെ? അനിക് ടോം, Advait Shaji, Advait Shaji is there? Advait Shaji.
Yes, sir. Yes. Yes, sir.
Yeah. Anik Tom is not there. Anik Tom. Anna Joseph. Anna Joseph ഇല്ലേ?
Yes, sir.
Yeah. ചെയ്തോ?
ചെയ്തു.
Okay. Okay, Anna, tell me. So just help me in drawing this. Okay. I am just isolating this. Okay. അപ്പൊ അന്ന പറയും എന്തൊക്കെ ഫോഴ്സ് ആയിട്ട് വരയ്ക്കാം. പറഞ്ഞോളൂ. അന്ന,
Gravitation force.
അതെവിടെ വരയ്ക്കണം? എവിടെയാണ്?
Gravitation force.
Gravitational force. Where should I draw it? Centering. Centering താഴോട്ട്, right?
Yes, sir.
Okay, fine. So this is the weight. Then what? അടുത്തത്.
Force exerted by the four blocks.
Which block? Red block. Okay, red block. അത് ഏത് ഡയറക്ഷൻ ആണ്? എവിടെയാണ് വരയ്ക്കേണ്ടത്? So let's say I'll mark the contact of red block. So something here. Okay. ഇവിടെയാണ് contact. In which direction?
Outward.
Outward, like this.
Inward.
Inward.
No.
Just towards the radius. അല്ലേ?
Yes. Yes, sir.
Just draw a line like this. So I'll call this as N. No? Any other force?
Force exerted by the blue box.
Blue box. Okay. So I'll just mark the contact. Maybe somewhere here. What is the direction?
Towards the radius, sir.
Towards the radius. Right. You can add force. Fine. So this is my free body diagram. Now I can idealize this. ഇതിനെ കുറച്ചുകൂടി idealize ചെയ്യാം. What I will do is I'll remove this box. I remove the circle. Circle I am assuming to be a point. I'll assume circle to be a point. Then I'll put forces on this. So this is my W1. Okay. You can draw like this. So this is my end. Let's say this is N2. You can write N2 or R2 anything. Okay. This is N1. Okay. Then also I can use transmissibility. Transmissibility in I can also draw this. So this is idealization. Then if I use transmissibility, what I'll get is
സാർ ആ ഫ്ലോർ മണ്ടക്കോട്ട് കിടക്കുന്ന ഒരു ഫോഴ്സ് ഉണ്ടല്ലോ.
ഏത് ഫ്ലോർ? Floor? Okay, fine. Okay, right. This force. So there should be force like this. N3. Very good. Okay. So let's say N3 is there. So N3 is, let's say N3 is somewhere here. N3. Okay. So transmissibility, I can make it more better. Okay, and of course better. Right. So this is my N3. This is my N3. This is my N1. This is my N2. This is my delta. Okay. So these are the forces coming. At first, these are the forces. Some of these forces may be zero also. So that depends upon equilibrium. We can do that, but we will not do all those things. But the idea here is you have to draw free body diagram. So it is very important to the missing part. I should not miss it. So it is very good that he has found that. Okay. So remember, this is how it works. Basically, then it is very easy for us to do all the calculations within the resultant and x dash equilibrium, y dash equilibrium, all those things we can check. Okay. So now what about this? Who was done for this? So it is rather simple, I guess. Who was done for this? So I'll delete from here. You can raise your hands. Altaf.
Yes, sir.
Altaf.
സാർ അത് മുമ്പേ ആ പടം വരച്ചവര് ഹാൻഡ് റൈസ് ചെയ്യാൻ പറഞ്ഞപ്പോ ചെയ്തതായിരുന്നു.
ഇത് വരച്ചില്ലേ?
ഇത് വരച്ചോണ്ടിരിക്കുകയാണ് സാർ.
Advishaji വരച്ചത്?
Yes, sir. Yes, sir.
Yeah, tell me fast. What are the forces?
Gravitational.
Gravitational, the center, downward.
Center. Yes.
Right. Then
Force from the side of the wall.
this wall.
Yes.
So what is the direction of the force?
Towards the center.
Towards the center. So we can close it. So we can hold this as N1. Any other force?
No.
No other force.
I think no.
No. What about this contact?
Towards the.
So then okay.
Okay.
So here, what is the direction of this?
Towards the center.
No, so what I'll do is I'll reduce this magnitude of this force. So, towards the center. Okay. Now I can, I can idealize this and I can use transmissibility. So what I can get is W is a weight. This is N1, then we have N2 also. So these are all the possible forces that can happen. Okay, this is the free body diagram. We can also say this is a free body diagram, but this both are free body diagrams. Okay, this is easier for us to do analysis work. Ideally, this is the free body diagram. Free body diagram, the technical term you see that. I hope this is clear. Now you can try with this. I'll give you 3-4 minutes. Try you. I need for 2 balls. I need free body diagrams. Okay. So if you're done, yeah.
So the force in the direction
നമുക്ക് ഇഷ്ടമുള്ളിടത്തോട്ടല്ലല്ലോ വരയ്ക്കുന്നത്. അപ്പൊ ഈ ഒരു നേരത്തെ എടുത്ത ആ ക്വസ്റ്റ്യനില് ബോളും മറ്റേ ബോളും തമ്മിലുള്ള ഈ ക്വസ്റ്റ്യനില് ആ വാളും ബോളും തമ്മിലുള്ള ഒരു കോണ്ടാക്ട് ഇല്ലേ, അത് തിരിച്ചല്ലേ വരേണ്ടത് ഫോഴ്സിന്റെ ഡയറക്ഷൻ?
No, it's okay because I am assuming it to be in this direction. But this is what you're telling.
അവിടുത്തെ
Why is it be in this direction?
അല്ല, ബോൾ ഒരു ഫോഴ്സ് കൊടുക്കുന്നില്ലല്ലോ, ബോൾ അല്ലേ ഇങ്ങനെ.
No, for every action there will be an equal and opposite reaction. If you are telling a ball how a ball ingine force കൊടുക്കണമെങ്കിൽ ball has to put a force in this direction. It has to always happen.
അപ്പൊ തിരിച്ചു കൊടുത്താൽ തെറ്റില്ലല്ലോ.
തിരിച്ചു കൊടുത്താലും തെറ്റില്ല. What will happen is if you write down the equilibrium equation, നിങ്ങൾക്ക് മനസ്സിലാവും. For example, ഇത് ഞാൻ സോൾവ് ചെയ്യാൻ ഇതിൽ I am telling it is in equilibrium. Equilibrium എന്ന് പറയുമ്പോൾ my forces in x direction should be 0. അല്ലെങ്കിൽ resultant in x, resultantന്റെ x component should be 0, resultantന്റെ y component also should be 0, right? So my force in the, let's say my force in the y direction, y direction, what are the force? The component of this force in y direction is n2. Okay, component of this force in y direction is minus w. This should be equal to 0 because it is in equilibrium. So that means n2 equal to w. We got a relation. Now what about horizontal direction? Horizontal direction, the forces in horizontal direction is, or horizontal component of the forces is n1 plus ഇതിന്റെ ഒരു കോമ്പണന്റ് ഇല്ല, ഇതിന്റെ ഒരു കോമ്പണന്റ് ഇല്ല. So that means my n1 is equal to 0. അപ്പോൾ നമ്മൾ അങ്ങോട്ട് വരച്ചാലും ശരി ഇങ്ങോട്ട് വരച്ചാലും കുഴപ്പമില്ല, കാരണം n1 ന്റെ വാല്യൂ ഇല്ല അവിടെ. It is not there. It comes out to be 0. Now as she was telling, let me say ഇപ്പം ഇവിടെ എന്തുകൊണ്ട് ഞാൻ ഇങ്ങനെ വരച്ചു, എന്തുകൊണ്ട് ഞാൻ തിരിച്ചു വരച്ചില്ല. So let's say I am taking this and I assuming this n2 should be in the opposite direction. ഈ n2 നെ ഞാൻ opposite direction വരയ്ക്കാം. Let's say ഞാൻ വരച്ചു കഴിഞ്ഞാൽ എന്ത് പറ്റും? Okay, ഞാൻ n2 നെ opposite direction വരച്ചു കഴിഞ്ഞാൽ now I will draw the Fibonacci diagram again. Fibonacci diagram, what I'll say is I have a w, I have an n2. So n2 is also coming from here. N2. Then I have a n1. Okay. So I can assume forces in up direction is positive, forces in down direction is negative. Okay. So again, this is an equilibrium. This is an equilibrium. The equilibrium. All the forces in next direction, all the components of the forces in next direction should be equal to 0. All the components of the forces in y, sum of the components of the force in x direction and z direction, y direction should be equal to 0. So if I say y direction forces 0 ആണെങ്കിൽ അല്ലെങ്കിൽ components 0 ആണെങ്കിൽ minus n2 minus w equal to 0, because y direction force in the താഴോട്ട് minus n2 ഉണ്ട്, താഴോട്ട് minus w ഉണ്ട്. So that means n2 equal to minus w എന്ന് കിട്ടും. ഇവിടെ നമുക്ക് കിട്ടിയ n2 equal to w ആണ്. അപ്പോൾ ഇവിടെ n2 equal to minus w എന്ന് പറയും. So it is telling w ന്റെ opposite direction ആയിരിക്കണം n2 എന്ന് എനിക്ക് ഓട്ടോമാറ്റിക്കലി പറഞ്ഞു തരാം. Right? So it is okay. നിങ്ങൾ if you draw it the other way also it is okay, because നിങ്ങൾ problem solve ചെയ്യുമ്പോൾ it will get automatically corrected. Here n2 it is telling it is minus w. Minus w എന്ന് വെച്ചാൽ ഞാൻ assume ചെയ്ത direction അല്ല, അതിന്റെ opposite direction ആയിരിക്കും അത്. ഈ കേസിൽ എന്താ പറ്റിയ, ഈ കേസിൽ n2 equal to w. That means n2 ന്റെ വാല്യൂ ഡയറക്ഷൻ ഒക്കെ സെയിം ആണ്. മനസ്സിലായോ?
മനസ്സിലായി.
So this is get automatically corrected. So if you draw like this also it is correct. This is correct. No problem with that. Only thing is when you do the analysis you will get n2 as minus w. The value will minus w. So it's okay. Actually ഇവിടെ n1 ഇല്ല because n1 is 0. But then we can assume force is there. But then നിങ്ങൾ equilibrium equation എഴുതി കഴിയുമ്പോൾ n1 ന്റെ value 0 ആവും. Okay. So don't worry about that. So now what you have to do is you should know how to draw this irrespective of the sign. Try to draw with for this. You can raise your hands. If you have done this, you can raise your hands. Anictome ഉണ്ട് ഇപ്പൊ. Anictome വന്നു. Altaf mute ചെയ്യൂ. So anyone has completed? We have to draw 2 balls here. 2 balls ആണ് നമുക്ക് വരയ്ക്കേണ്ടത്. Any one ball. Anyone has completed? Ansi Pradeep. Ansi Pradeep. Ansi Pradeep, unmute you. കയ്യിലെന്ന് പറഞ്ഞാൽ മതി. Ansi Pradeep ഉണ്ടോ അവിടെ? Not do this. നിങ്ങൾ ഓൺലൈൻ എവിടെയും പോകരുത്. It is very bad. Okay. Arjun Ajimon is there? Arjun Ajimon?
Sir, ഉണ്ട്.
ചെയ്തോ?
Sir.
എന്നാ പറ. Let's do that. So first ball, this ball. Okay. So I think I have to mark this ball. Okay. Tell me, what are the forces?
Weight.
So
Downward.
weight is down. Okay. Then?
And contact force.
So which contact? This is one contact, the red one. The other is, let's say, yellow one. So this is my, somewhere here is my red contact. Yellow. So my yellow contact is here. My red contact is here. Okay, tell me.
Toward the red one will be inwards. Toward the center.
Center. Okay, towards the center. So in the actually this line.
Then same as yellow. Same as red. Yellow also. And the contact force due to other spheres.
Oh, good, very good. Okay, contact to other spheres. So which direction you want to draw that?
Toward inwards.
Inwards. Okay, you can draw in any direction. It doesn't matter. But then let's see. I will draw it inwards. So I'll call this. So I'll have to name this thing. N2. So let's call this N3. Okay. Now what about the others? Here, this.
Sir,
Vijio.
Sir. Contact force due to a sphere.
So just mark this. So in what direction?
Inward.
So it is very critical here. At this point you have to remember, because this force are equal and opposite. These forces equal and opposite. Okay. So that means
we can draw outward.
Okay. So this, if you are drawn inward, this also you have to draw inward. If you are drawn this as outward, this also you have to draw outward, because it should be equal and opposite direction. In the direction, in the opposite direction, you can see this. Okay. So this also should be same magnitude. If you see this contact, so there is a force. This direction, this is the force in this direction. You can say like that. Okay. It should be equal and opposite. So N3. Any other forces?
Weight.
So wait, it may be W2. Let's see. Then any other force?
The contact force.
This one. So this also will draw the inward direction. Right?
Yes.
N4. Okay. Good. So I'll directly draw the idealized form. So this is one force. Then we have a normal force in this direction. Then we have a force in this direction. Then we have a force in this direction. Okay, so this is for this body. What about this body? This body, I have a force in this direction. I have an N4 in this direction. Then I have an N3 in this direction. So these are the equilibrium. These are the free body diagram. And now, if it is in equilibrium, all the components in x direction should be equal to add to 0. All the components in y direction should add to 0. So this is that we will do in the later part. Okay. So similarly, this should take up. You draw this up on a sphere order. Sphere diagram. Okay. So I'll tell you when to do this. So today we do. You do this. In addition to that, I think we should solve now. Go and solve the this problem. Right, this problem. Now, what I will do is, without this force, I have drawn the free body diagram. Without the force, I have drawn the free body diagram. Okay. This, if you see, now, if this is an equilibrium, so we'll talk about equilibrium now. So let's say duplicate this. This nonsense. So this free body diagram, I'll just draw it here. So we have an N1 in this direction. N1. Then we have 8 in this direction. Then we have a normal force upward. So I'll call that as N2. This is a free body diagram. Okay. Now, again, let this be at some angle theta. So theta we can find. Let this be theta. Let this be theta. Okay. Now I will remove all these things because of the previous slide on the. Now I will be dealing with this case. This is what I will be using. This body, entire body, I have reduced to this. Okay. Now it is in equilibrium. It is in equilibrium. So this implies component of resultant. The x component of resultant equal to 0. So this is same as summation of forces in x direction should be equal to 0. Okay, because all force in the x direction of the component should be equal to 0 because it is an equilibrium. Then the y component of resultant is 0. So that means summation of forces in y equal to 0. So now when I am drawing, writing it is equilibrium, I will be using these forces. These two notation. All the forces in the x component should be summed to 0. All forces in the y component should be summed to 0. Okay. So what I will draw now is, so let's say, let's remove this also. I feel maybe I'll keep it here. This. Now let's say summation of all the forces in x equal to 0. The force in the x component should be equal to 0. Now, W1 the x component is 0 because it is in vertical direction. And I will assume towards the right is positive. Towards the right is positive. Okay. Then this force as a x component and y component. That is the N1. N1 the x component is minus N1 sine theta. Right? So this is the y component. dy common n1 sin theta. So it is in this direction, opposite direction, negative direction. So I am writing is minus n1 sin theta. Is there any other forces? No. So this should be equal to 0. So this gives me theta cannot be 0 because theta there is a value n1 equal to 0. N1 equal to 0. This is what we are getting. Okay. Now summation of forces in y direction equal to 0. So that means I can assume up positive, upward positive on again. I can write up is I have an n2, I have a w. So w is downward minus w. I also have a component of n1 in this direction, that is n1 sin theta. Okay, so that is upward. N1 sin theta equal to 0. Now we know that n1 is 0, so this vanishes. This vanishes, and what is pending is we get n2 equal to w. Okay, so this is what we call as a solution. Then there is a problem number solve which they can. So that means I can write what we have is we have a w in this direction. We also have an n2 which is equal to w in this direction. This is the body of force. Okay, n2 and this force is not there. There is no force here because it is a plastic condition. The force will act. So this touch, even if you remove this block, nothing will happen to the body. It will be in. Okay, so this is how we use what you say equilibrium equations. Use that we are finding the forces in the contact force. Right now, we have to go to a problem. So the problem is. Okay, so we have to now draw the free body diagram of this body. So in the question, we are starting to apply some force in this direction. Okay, and the question is weight of the roller is 1000 Newton. Find the minimum force required to move the roller. So now what I will do, I'll quickly draw the free body diagram. I think now you can appreciate this. Okay. So I'm going to quickly draw the free body diagram. So what is the weight? I have a weight here. The magnitude of weight is 1000 Newton. I'll directly write that. It's a force, so 1000 Newton is correct. Then what we have? I have a contact force. N1. Okay. Now, what is this angle? We will talk about that. Then we have another contact force, N2, possible. N2. Okay. Now, before that, can I find this angle? Can anyone help me finding this angle? So this is what is given to us is this is 300. The radius of the roller is 301. So this is 300. Okay, and we know this is 150. This is 150. This is 150. So that means anybody line velocity if I project it here. So this distance is 150. 150. Okay. Now this is also radius. This is also radius, right? So I can always say this value x. X is equal to 300 minus r cos theta. Now what is theta? This is theta. Okay. So this is r. So if you draw that triangle out here, triangle this is 300 or r. This is r. This is theta. So this is r cos theta. Okay. Also, this is also r. Total length is also r. So we can write r cos theta or this distance r cos theta x this x distance is equal to so this x distance is so we can say that this is 150. This is 150. Okay, so r minus r cos theta. This is r minus r cos theta should be equal to 150. That is what I should have written. Okay, so that means r minus r cos theta should be equal to 150. Again, another. This is r minus r cos theta is 150. So r into 1 minus cos theta equal to 150. 1 minus cos theta is equal to 150 by r. R is 300. So that is half. So that means cos theta equal to half. So this gives me cos theta equal to, so cos theta is equal to 1 minus 1 by 2. 1 by 2. So that means theta is equal to 60 degree. Theta equal to 60 degree. Okay, so this 60 degree. So we get all force. Oh, there is one more force, our main force. P. No, here you have to use an intelligent guess here. Intelligent guess. The question is, what is the value of P for which I will lose this contact? It will just move. What is the minimum force required to move the roller? Move the roller the just about this point I will not go on. You can see this about this point, about the support. About this support so basically the contact the ground should go. Okay, so let's say P is that force for which it is doing that. Okay, so let P be the force. For which the roller loses contact. Okay, so then what happens is at P apply this contact is lost. So once the contact is lost, this force will be vanishing. Okay, so before that I will draw this free body diagram here. Reduce idealized free body diagram. So this is my P. This is my N1. This is my N1. This is my 1000. This is my N2. N2. And what is this angle? This angle. So I know this angle is theta. So this angle also will be theta. Right? Use this. No. So when it loses contact, I can easily remove this. Okay, so that means I can remove this force. E condition P in the value. Okay, now we know that equilibrium. So equilibrium because it is just moving. Okay, the movie just moving. There also we can assume equilibrium. So summation of forces in X should be equal to 0. Summation of forces in Y should be equal to 0. Okay, now let's say what we should do now. Let's say we will do summation of forces in Y direction equal to 0. Y direction equal to 0. Y direction of forces. What are the forces in Y direction? Okay, so P doesn't have any component in Y direction, so that is 0. Then I can assume up to be positive. Upward should be positive. So there is a 1000 which is acting downward, so this is a minus 1000. Minus 1000. Okay. This 1000 is upward. Then we have a component of n1 in this direction. There's a component of n1 in this direction.
Sir,
Yeah. Tell me. എന്താ പറഞ്ഞേ?
ആ ഫോഴ്സ് എൻഡ് ഉണ്ടല്ലോ, കോണ്ടാക്ട് ഫോഴ്സ് മറ്റേ മണ്ടക്കോട് കൊടുക്കണം, അതിനെ അങ്ങ് എടുത്ത് മാറ്റി.
അതിനെ മാറ്റാനുള്ള കാരണം അത് ജസ്റ്റ് കോണ്ടാക്ട് പോകുന്ന കേസാണ് നമ്മൾ നോക്കുന്നത്.
എന്ത് സാർ? ജസ്റ്റ്
അത് ജസ്റ്റ് കോണ്ടാക്ട് പോകുന്നത്, ജസ്റ്റ് പൊങ്ങുന്ന ആ ടൈമാണ് നമ്മൾ നോക്കുന്നത്. അതുകൊണ്ടാണ് ടച്ച് ഇല്ലെങ്കിൽ there will be no contact force, right?
അപ്പൊ ഈ വെയിറ്റ് കാരണം താഴോട്ട് പോകത്തില്ല സംഭവം, ഇക്വിലിബ്രിയത്തിലാവത്തില്ലല്ലോ.
അല്ല, ആ വെയിറ്റിനെ അത് വിൽ സീ ദാറ്റ്. അപ്പൊ എന്ത് പിയിലാണ് അത് സംഭവിക്കുന്നതാണ് നമ്മൾ നോക്കുന്നത്. ഇത് നമുക്ക് സോൾവ് ചെയ്യാൻ മനസ്സിലാവും. സോ വാട്ട് വിൽ ഡു ഇസ്, നമ്മൾ ടൈം കഴിഞ്ഞിരിക്കുന്നു. സോ വിൽ സ്റ്റോപ്പ് ഫോർ ദ ഡേ. യു ട്രൈ ടു, നിങ്ങൾ എന്താ ചെയ്യേണ്ടത്, ഇത് ഈ ഒരു കണ്ടീഷൻ വെച്ചിട്ടുള്ള ഇക്വിലിബ്രിയം ഇക്വേഷൻ നിങ്ങൾ എഴുതും. സോ ഹിസ് ഡൗട്ട് ഈസ് വെരി വാലിഡ് ആൻഡ് ഇറ്റ്സ് വെരി ഗുഡ് ദാറ്റ് ഈസ് ആസ്കിംഗ് ദാറ്റ് ഡൗട്ട്. ഓക്കെ, ബിക്കോസ് ദാറ്റ്സ് എ വെരി ഗുഡ് തോട്ട്. But then this will, you solve it, you will get the answer also. Okay, we'll do this tomorrow. What you do is you try to solve this. Okay, summation of f in x direction equal to 0. This rendu ningal cheyidu kayna you get some value of p and n1. Okay, so you have to tell me what is the value of p1 and that's what is the value of n1. This rendu ningal paranju. Okay, so what I will do is I will stop for the day. Please fill this form. There is one more form you have to fill. Okay. So I am ending the meeting.